welcome back. Or, if it's your first time watching, welcome. Truth tables can be used to test whether two statements are logically equivalent. And in this video, I'm going to show you how to do that. But before we get to that, first we should talk about what it means for statements to be logically equivalent. Then, after that, we'll go ahead and we'll work through a few examples. First, remember that truth tables represent every single possible arrangement of truth values for some set of statements. You can think of each row on the truth table as one possible world. And the entire truth table then, of course, represents all of the possible ways that things could have been, again, just for the set of statements that we're considering. You should check out my video, What Truth Tables Do, for more information on what truth tables are all about. Two statements are logically equivalent, then, if both statements have the exact same truth values on every single row of the truth table. To put things differently, if two statements have the exact same truth values in all sets of circumstances, then you know that those two statements are logically equivalent. If they don't, then they're not logically equivalent. And that's all there is. It's that straightforward. But it's really important to note that logical equivalence is not the same thing as semantic equivalence. The mere fact that two statements are logically equivalent does not mean that those two statements mean or express the same thing. I know that might seem strange at first, but the mere fact that two statements are true or false under all of the same sets of circumstances doesn't mean that they express the same content. And I'll say more about this at the end of the video. For now, let's just go ahead and work through some examples. So there are actually two different ways that you can test, and which one you'll be expected to know really just depends on your professor. So we'll work through both of them, and I'll go ahead and start with the easier, more straightforward method of testing for logical equivalence. All right, so let's begin by just testing two simple statements to see whether they're logically equivalent. We have statement 1, which is not P or Q, and we have statement 2, which is if P then Q. For the first method, you simply set up your truth table as normal, and each statement gets its own column. Then you go ahead and you evaluate each statement. If you need a refresher on how to do this, I have a number of videos that teach you how to evaluate the logical connectives. Plus, I also have some practice videos that might be helpful. In this particular video, I'm just going to go ahead and breeze right through evaluating these things. Let's go ahead and start with the statement on the left. We'll go ahead and evaluate the negation first. That's just going to be false, false, true, true. And now I have everything that I need to evaluate the entire disjunction. I'll go ahead and highlight the values for the main connective, just to keep things nice and clear. Now we can go ahead and evaluate the conditional, which is just a regular typical conditional, so this will be pretty straightforward. And I'm going to go ahead and highlight these as well, just for the sake of consistency. Finally, all that's left to do is just to check to see whether they're logically equivalent. As we can see, both statements have the exact same truth values on every single row. So, given that they have the exact same truth values on every single row, we know that these statements are logically equivalent. And that's all there is to the first method. Now let's go ahead and consider the second. The second method requires just a little bit more work. All right, so let's use these statements. P and not Q, and a negated conditional, not P implies Q. So as before, we're going to go ahead and set up our truth table. Only this time, rather than having two columns, we're going to grab both of our statements and join them together with a biconditional. This method exploits the fact that biconditionals are true when both of their components are the same truth value and false otherwise. You can probably already see where I'm going with this. If the two statements are logically equivalent, then the biconditional will turn out to be a tautology, which is just to say every single row will turn out to be true. And I have a video already uploaded on how we evaluate tautologies using truth tables. So we'll go ahead and start by evaluating the statement to the left of the biconditional first, and then we'll go ahead and evaluate the statement to the right of the biconditional. And now that we've got both sides evaluated, we can go ahead and evaluate the biconditional itself. As you can see, in this case, the biconditional turns out to be true on every single row. So this biconditional is a tautology, and we know that both of the statements must be equivalent, logically equivalent. You might notice that this requires some extra steps, so personally, I prefer the first method. All right, so those are the two ways that we might go about testing whether two statements are logically equivalent. But I did say at the start of the video that logical equivalence is not the same thing as semantic equivalence. Again, that just means that the mere fact that two statements are true or false under all of the same sets of circumstances does not mean that those two statements express the same content or that they mean the same thing. The easiest way to prove this is by thinking about tautologies and contradictions. Tautologies are all statements that are always true, and contradictions are statements that are always false. This means that all tautologies are logically equivalent with one another, and that all contradictions are logically equivalent with one another. And yet it's pretty clear that plenty of tautologies mean different things, and that plenty of contradictions also mean different things. For example, if the statement letter A stands for I am 33, and the statement letter B stands for that is a dog, you can construct the contradiction I am 33 and I am not 33, or represented A and not A, and you can construct the contradiction that is a dog and that is not a dog, or B and not B. Both of these statements, as this truth table shows, are logically equivalent, and yet they clearly mean different things. One statement is about my age, and the other statement is about whether something is a dog. Consider the statements of math. That 2 plus 2 equals 4 and that 3 plus 3 equals 6 are clearly different statements that express different things. But they're also both tautologies, so they are logically equivalent, which is just to say they're always true. So it just kind of follows really trivially that they're going to have the same truth values under all sets of circumstances, because they're going to be true under all sets of circumstances. So make sure that you keep these concepts apart. Truth tables tell us only whether the statements are logically equivalent. The truth tables, however, can't tell us anything about what the statements themselves actually mean. And with that, we've covered everything that matters when it comes to testing whether statements are logically equivalent with truth tables. If you want to watch more videos like this one, where I cover either concepts in philosophy or concepts in logic, you should consider subscribing. Thanks for watching, and I'll see you next time.